Okay, so today's notes are on composite functions. It's section 6-6B. And our content objective is to find the composite of two functions, and our language objective is to use the correct terminology to explain composite functions. So we're going to start by defining what those actually are. So a composite function is when the output of one function becomes the input of another, or the other. So just for a quick little visual to hopefully demonstrate what I'm talking about, if I have the input of a function, we'll say f here, which this would be the domain if it's the input. That when I plug that into the function, that generates the output of f, which is the range of f. And when we have a composite function, what happens is the output there of f becomes the input of a new function or a different function we'll call g. But then when we plug that in, the new output the output of g of f of x is the result. So this is again the domain of g, and this one right here will end up being the range of g. So again, you take one function, plug stuff in, you get an output. That output is then plugged into the other function, which then gives us the final output, which is the final range. So when the output of f becomes the input of input of g, when the output of f becomes the input of g, it is written as g of f of x. And notice that this is the open circle. So again, this is different from multiplication. When you have an open circle with two functions, it implies a composite function, and it's read g of f of x. And it means that we have the function g, and we've plugged in the function f of x into that function. So what this means is we would first evaluate f of x, and then once we got that value, we'd plug it in and use it as the new input for g. So this becomes the new input for g. So we plug it in there, plug it into g. One thing I want to note that's going to be important, g of f of x is not equal to f of g of x. So one important thing to note is that the order in which you write them does matter. So Goff does not equal fog. They are not the same thing. Plugging in f to g is not the same as plugging g into f. So make sure that you know the order matters. Okay, so that's the main gist of composite functions, but what does this actually look like with functions? I'm going to show you an example, but I'm going to flip the page. So our first example, and while I'm writing this example, send me a quick email and let me know you're actually listening to these notes. So while I write this example, send me this email, but I want you to let f of x equal x minus 5 and g of x equal x squared. And I want us to determine what is g of f of -3. So there's two methods, and I'm going to go through both so you can sort of see how they're similar and different. So method 1 I will label here. We're going to start method 1 by substituting the entire function f of x into g of x. So I'm going to take this whole function and plug it in here. So if I have f of x equals x minus 5 and g of x equals x squared, what I'm doing is taking this whole thing and plugging it in here. So that's going in for x squared. So g of f of x becomes x minus 5, that whole thing squared. So that is my new composite function. Now for step 2, since I'm specifically finding the value when I plug in -3, that's what I'm going to substitute for x. So this becomes g of f of -3, since I'm plugging that in for x, and I get -3 minus 5 squared, and then I'm just going to evaluate that. So when I calculate that out, -3 minus 5 is -8 squared. -8 squared is positive 64. So that would be my answer for that problem. All right, so now I'm going to do the method number 2. So that's our answer. It is correct. But now if we use method 2, the first thing I'm going to do this time is instead of substituting the entire function in, I'm just going to plug in -3 to the inner function. So I'm going to substitute -3 into x in the function f of x. So I have f of -3 equals, and I'm just plugging that in for the x value there. So I have -3 minus 5, and I get -8. So I'm substituting -3 just into the x of the inner function. And then when I get the value, -8, step 2, I evaluated it. Step 3, I'm going to substitute that value I got, -8, into x in g of x. So now I'm just plugging that into the outer function. So then I have g of -8 equals -8 squared, which again is just 64. So it is pretty much, or that step 4 was evaluate. It is pretty much this, you end up with the same answer, and it's a very similar process, especially when they're pretty simple looking like this, or pretty simple functions. But as you can see, they are slightly different. One, you plug the whole function in first and then plug in the number. One, you plug in the number to the first and then plug in the new number to the second. So for our quick check, last part of our notes for today, using the same functions from the example, what is this time fog of -3? So instead of g of f, I want you to figure out f of g using the same functions. Pause it, try it on your own. I'm about to go over it. So I'll do method 1 over here, and then I'll go over method 2. So in this case, I'm plugging my function g of x into f of x. So this becomes f of g of x, which is going to be x squared minus 5. And then because I plugged in x squared, this function, into the x here. So then I'm going to plug in my value that I'm evaluating for, -3. So I have -3 squared minus 5, which becomes 9 minus 5, which is just 4. And that is my answer. So then there's method 2. So if you prefer method 2, I'm going to plug in -3 into g first. So when I do that, I get -3 squared, which becomes 9. Then I'm plugging 9 into f of x. So I get f of 9, which is 9 minus 5. And that gives me 4, which is, again, the same answer. Sorry, I cut that off. My bad. I did not realize you could not see that. But hopefully you can see it now. Check your answers. Make sure you write down any questions, comments, concerns you have on these notes so we can go over them together in class.